Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0502, for the Honda Fit from the model years 2015 to 2020 indicates a malfunction within the continuous variable transmission or CVT speed sensor circuit. It specifically highlights an open or short circuit within the system, meaning there is an electrical issue rather than a mechanical problem in the transmission. The CVT speed sensor itself plays a crucial role in monitoring the rotational speed of the transmission fluid, sending necessary signals to the powertrain control module, PCM, for optimal functionality. Problems at this level can lead to poor vehicle performance, as the PCM relies on accurate data for smooth gear transitions. Identifying this code requires systematic troubleshooting, aimed at the electrical connections and wiring that facilitate communication between the CVT speed sensor and the PCM. The troubleshooting process must begin by verifying the presence of the DTC and checking connections, always prioritizing safety and vehicle stability during the procedure. The CVT speed sensor is critical for monitoring the operational status of the vehicle's transmission system by accurately reporting the transmission fluid's rotational speed. Its primary role is to inform the powertrain control module, PCM, of any changes in speed, which allows the transmission to adjust accordingly for smooth performance. This sensor is typically located on the transmission housing, making it accessible during routine inspections or repairs. The corresponding wiring connects the sensor to the PCM, consisting of a 3P connector that includes vital terminals. The sensor's performance can be compromised if there are issues such as broken wires, poor connections, or corrosion at the terminals. As the CVT is simpler in design compared to conventional automatic transmissions, errors in the electrical circuit can quickly lead to erratic behavior in shifting. Understanding the layout and function of these components is vital for accurately diagnosing DTC P0502. The possible causes of DTC P0502 primarily revolve around electrical faults rather than mechanical failings. The first likely issue is a failure in the electrical circuit, which may present itself through damaged wiring or poor connections. Such faults can prevent proper data transmission between the CVT speed sensor and the PCM, leading to erroneous readings or a complete lack of signal. Another significant factor is the physical condition of the wiring connections. Loose or corroded terminals can easily disrupt the electrical flow, resulting in sensor malfunction. Lastly, if the wiring and connections are confirmed to be in good condition, the fault may lie within the CVT speed sensor itself, which could be defective and in need of replacement. It's essential to assess each of these areas carefully to determine the root cause before proceeding with repairs. The first and most visible symptom of DTC P0502 is typically the illumination of the check engine light on the dashboard. This warning signals that something is wrong within the vehicle's engine or transmission monitoring system. In addition to the warning light, drivers may notice erratic gear shifting behaviors, which could manifest as rough transitions or delays during acceleration. These shifting issues can significantly affect the driving experience, leading to unpredictable performance on the road. Furthermore, a reduction in acceleration performance may also be evident. If the speed sensor fails to relay accurate information, the vehicle may struggle to maintain optimal speeds or demonstrate sluggishness during acceleration. Recognizing these symptoms early can help in identifying and rectifying issues associated with DTC P0502 to ensure better vehicle performance. The first step in troubleshooting the DTC P0502 is to verify that the vehicle is in the on mode, indicating that electrical systems are operational. This is crucial for allowing communication with the diagnostic tools necessary for this process. Following this, the next action is to clear the DTC using the Honda Diagnostic System, HDS. Clearing the DTC essentially resets the system and allows any current issues to resurface, providing a clearer picture of whether the fault is intermittent or persistent. It's important to note that if the DTC reappears after this clear procedure, it indicates that there is a necessitated root cause that needs addressing. At this stage, ensuring that all connections are secure and there are no signs of corrosion is also a good practice before moving to subsequent troubleshooting steps. In this second step of the troubleshooting process for DTC P0502, one must turn the vehicle to the off, lock mode. Upon safely positioning the vehicle, the next critical step involves disconnecting the CVT speed sensor by removing the 3P connector. This action isolates the sensor from the electrical system, allowing for precise testing of the wiring and connection integrity without interference. After disconnection, it's critical to proceed with electrical testing to identify voltage and continuity issues. Isolation of the sensor is an essential process that enables the technician to conclusively determine whether the problem lies within the sensor, its circuit, or elsewhere in the transmission system. Accurate procedures at this stage are vital for diagnosing the electrical issues effectively. For Step 3 in troubleshooting DTC P0502, one must measure the voltage between the established test points while the vehicle remains in the on mode. This involves checking the voltage between test point 1, corresponding to the CVT speed sensor 3P connector number 3, and test point 2, which connects to body ground. The expected voltage in this scenario should be approximately 5 volts. Achieving this voltage indicates that the electrical supply connecting to the CVT speed sensor is operational and functioning correctly. If about 5 volts is observed, the next step would be to check continuity and integrity in related circuits. Conversely, if the voltage is not present, the technician must consider potential open circuits, indicating issues that need to be repaired before proceeding further. In the fourth troubleshooting step for DTC P0502, further checks need to be performed on the VCC2 line, which is essential for the operation of the CVT speed sensor. At this point, the same test methodology applies, measuring the voltage between test point 1 related to CVT speed sensor 3P connector number 1 and test point 2, which again connects to body ground. The anticipated outcome is a voltage level nearing 5 volts. A proper reading here signifies that there is no open line affecting the VCC2 wire that leads back to the PCM. If this voltage check is positive, the next step can advance without issues regarding this line. However, if 5 volts is not detected, it is paramount to inspect the wiring for any damages, and repairs would need to focus specifically on the VCC2 wire to restore proper function. The fifth step in the troubleshooting process for DTC P0502 involves examining potential wire shorts on the VEL-DD line. To begin this step safely, the vehicle should be turned to the off mode, followed by jumping the SCS line using the HDS. After securing the necessary preparations, disconnect the PCM connector C51P from its terminal. This action is vital to isolate the systems during continuity testing. The next task is to check for continuity between the first test point at CVT speed sensor 3P connector number 3 and the second test point at body ground. If continuity is detected, it indicates a short to ground exists in the VEL-DD wire between the CVT speed sensor and the PCM. Should this be the case, repairs will directly address areas exhibiting this short circuit condition to prevent further malfunctions. During the sixth step of troubleshooting DTC P0502, the technician focuses on checking the continuity of the VELDD line. The vehicle must again be in the off mode, with the connections previously mentioned disconnected to ensure safety and accuracy during testing. Continuity must be checked between the test points. The first at CVT speed sensor 3P connector number 3, and the second at PCM connector C 51P number 32. If continuity is confirmed, this indicates that the VELDD wire is functioning correctly. In this event, it would be necessary to consider updates for the PCM software or substituting it with a known good PCM to eliminate software issues. If DTC P0502 clears following this verification, troubleshooting can conclude satisfactorily. However, if no continuity is detected, repairs focused on the VELDD wire become a priority. In the final troubleshooting step for DTC P0502, the focus is on performing a comprehensive check after ensuring all connections and components are restored to their operational state. Start by reconnecting all previous connectors securely, ensuring that there are no loose or improperly seated connections. The vehicle should then be turned to the on mode, and the DTC should be cleared using the HDS. Following this, a relevant function test is necessary. By entering the VSA maintenance mode and conducting a test drive at a speed of 37 miles per hour, 60 kilometers per hour, or higher, one can gauge the operational status of the sensor. After completing this test drive, return to the HDS to check for pending or confirmed DTCs. If DTC P0502 reappears, replacing the CVT speed sensor is necessary as it may be faulty. If the DTC does not reappear, further checks may focus on the PCM for software updates or replacements if required. Final repair verification is imperative to ensure that all remedial steps taken in response to DTC P0502 have been successful. The first action is to confirm that the DTC has been cleared from the system, indicating that no lingering issues remain. Following this, verifying the functional status of the CVT speed sensor is vital to ascertain whether the root cause has been addressed comprehensively. A diagnostic tool, such as the HDS, should be utilized to perform a function test and confirm that no new DTCs arise, demonstrating that the sensor communicates effectively with the PCM. If the repair methods effectively restored function without further issues, the vehicle should now perform optimally. This final step serves to validate the success of the troubleshooting and repair process. Preventive maintenance is essential for maintaining the integrity of the CVT system and minimizing the risk of DTC P0502 recurring. Regular inspections of electrical connections and wiring should be performed to identify any signs of wear, corrosion, or poor connections. These preventative actions make it possible to catch issues before they escalate into significant faults causing system disruptions. Additionally, it is advisable to periodically clear diagnostic data to refresh the system and ensure that no unresolved electrical codes persist. Keeping the PCM software up to date is another effective strategy in preventing future occurrences of DTC P0502. Monitoring the vehicle for irregular behavior during driving can also provide early warnings of electrical issues that may need attention. In conclusion, DTC P0502 specifically indicates electrical issues within the CVT speed sensor circuit, requiring systematic troubleshooting to accurately diagnose and repair. Understanding the role of the CVT speed sensor, its connections to the PCM, and potential causes of malfunctions is essential in effectively resolving the issue. By following the structured troubleshooting steps laid out, technicians can pinpoint the source of the problem and implement the necessary repairs or part replacements. Furthermore, regular preventive maintenance practices can greatly reduce the likelihood of future occurrences of this DTC by ensuring the wiring and connections remain in good condition. Ultimately, ensuring the transmission system functions as intended is vital for optimal vehicle performance and safety. Please like and subscribe to the channel. See you next time.